Alright, the other trig functions part 2. So we'll be dealing with the following: secant and cosecant. Right? So you're dealing with those two. Let's keep in mind that I have this y equals 3 secant x, and we should know what the y equals secant x graph is, right? And that would be, as if it was, well, that was 1, it'd be there, and then this would be halfway at pi over 2, right? And then down here, at 3 pi over 2, we're down here, right? So how does it change when we have a 3 up front? Well, we're going to go up 3 instead, and it's going to go up here. I'm going to do a different color just to... And then at -3, so we're down here. So that would be what y equals 3 secant x would look like. It would change where we're starting these almost parabola-looking portions of our graph. So we have y equals 1/2 cosecant of 3x. And in order to graph this most accurately, the best way to go about this is to start off by graphing y equals 1/2 of its reciprocal, which is sine. Okay? So 1/2 sine of 3x. We'll start at 0, 0 like we would. And then from there, so one period is 2 pi over 3. So we'll call this 2 pi over 3. Halfway would be pi over 3. And I'm going to do a dotted line so that we're not confused. I'm going to go up to 1/2 and down to -1/2. Right? And then what are these points here? Halfway between 0 and pi over 3 is going to be pi over 6. Pi over 6, and halfway between pi over 3 and 2 pi over 3 is pi over 2. Now, how does this help us? Well, now we can draw our asymptotes. Everywhere it crosses 0 will be an asymptote. Right there. Okay. And then what we're going to do is reflect it right over where these points are at their mins and maxes. So reflect up and reflect down. Okay. And there is a graph of y equals 1/2 cosecant of 3x. All right, so we got a more difficult one right here with secant. So similar to the last one, we need to think about drawing its reciprocal first, which is cosine. Okay, so we graph this first, just like we did in a previous section. Then we'll be able to graph secant as once we graph cosine. So we put that in between 0 and 2 pi. Okay, and now we are going to isolate x. Okay, and then we're going to divide everything by 1/2, which is going to get me, I'm going to go over to the right here, and we're going to get 2 pi over 3 is less than or equal to x. That's less than or equal to 14 pi over 3. Okay, giving us, if you're trying to find out what their period is, period would be 4 pi. All right, so let's graph. Okay, so we're shifting down 2 with the original graph, okay? So since we're shifting down 2, Instead of it being between -1 and 1, we'll be in between -1 and -3. So we're going to be down here some. Let me extend this a little bit. So between -1 and -3 for our cosine graph. And when we graph it, we're gonna be amplitude's 1, so we start up top here. Except we're moving over to pi over 2 pi over 3 rather. And we'll be plotting it right there. And then going all the way to 14 pi over 3. And we'll be going right here. Okay? And then what's happening between halfway between these two values will be 8 pi over 3. And I should make that dotted because it's not actually what the graph we're looking for is. We're looking for secant. So let's make this a little dotted. There we go. So that's from 2 pi over 3 to 14 pi over 3. Now, where will our asymptotes be for this particular graph? What values would make this portion 0? The asymptotes will be the halfway points right here. Okay. It would be 5 pi over 3. And halfway between here is 11 pi over 3. So therefore, when we graph this, we'll be flipping up here. For our actual graph, let's use red for the actual graph. And then we'll be flipping down here. And then we're reflecting up here. Okay? And what's in red is our actual graph. Okay? And that's it. Appreciate you watching. We'll see you in class.